Hi, hello. My name is Akash Biar, and I'm a student of Sri Venkateshwara College of Engineering, 1VE 23IS003, and I'm pursuing my third semester. The course code is BCS 304. Our course title is Data Structures and Application, and we are going to discuss about the topic is static hashing. Static hashing. Yeah, let's discuss about what is hashing. Hashing is a technique which we use to store and retrieve data efficiently. It involves using a hash function to mapping data to fix a range of values called a hash table. Hashing is used widely in computer science, especially in databases, caching, and searching. What does static hashing mean? In static hashing, the size of hash table is fixed once the table is created. Its size cannot change. Whether this is ideal for situations where the number of elements to store is known in advance. Key concepts in static hash function. A hash function makes an input key and converts it to an index for the hash table. A good hash function minimizes collisions, ensuring keys are disturbed evenly. Examples in C: int hash function, int key, int table size, return key table size. Here we use the modulo operator to calculate the index. Hash table. A hash table is an array where the hash function determines the location for each key. Examples for hash table in creation in C. Collisions. Collisions occur when two keys map the same index. For example, int key 1 is equal to 15, int key 2 is equal to 25, int index 1 equals key 1% 10, index is 5, int index 2 equals key 2% 10, index is also 5. Collision resolution techniques. Chaining. Use a linked list at each index to store multiple keys. Open addressing. Find another empty slot in the table. Examples of chaining in C. Struct node, flower bracket into data, struct node into next. Closing flower bracket, struct node in hash table 10 equals null. Steps to implement static hashing in C. Let's go through a simple implementation of static hashing. Defining the hash table, declare an array for the hash table or an array of linked lists for chaining. Writing the hash function, use a modulo operation for simplicity. Insertion, place the key at the calculated index, handle collisions using chain or opening addressing. Example of insertion and chaining. Void insert int key flower bracket int index equals key percentage 10 struct node into new node equals struct node into malloc size of struct node new node data equals key new node next equals hash table bracket index hash table brackets index close the brackets equals new node semicolon close the flower brackets. Search. Use the hash function to locate the index, then transfers the chain to find the key. Deletion. Locate the key using the hash function, then remove it from the chain or table. Applications of static hashing. Databases. Hashing is used for indexing to allow fast data retrieval. Example, searching for a record by an ID number catching. Caching. Web browsers use hashing to store cache pages or data efficiently. Compilers hashing ellipse and symbol tables which store variable names and addresses. Password storage. Password storage hash functions like MD5 or SHA are used to store hashed passwords. Data deduplication. Hashing helps identify duplicate data by comparing hash values instead of actual data. Advantages and disadvantages. Advantages: fast data insertion and retrieval, simple to implement in programming languages like C, predictable memory usage due to fixed table size. Disadvantages: static hashing doesn't adapt well to changes in the number of elements. Collisions can slow down operations if not handled efficiently. Conclusion: static hashing is an efficient and straightforward technique for storing and retrieving data. It is particularly useful when the data set size is fixed or predictable. Using C, we can easily implement static hashing with changing for or opening addressing. Thank you, guys.